Hello everyone. So today we have a Div-4 Codeforces now. This is going to be my first Div-4 round. I missed the first one due to college exams, but today we are doing it. Let's see how it goes. Also, the contest is delayed by 10 minutes. Right? The number of participants is too much. We have too many participants. 25,000 approximately. A ticket is a string consisting of 6 digits. A ticket is considered lucky. The sum of the first 3 digits equal to the sum of the last 3 digits. Unit-ticket output if it is lucky or not. It may have leading digits. So yeah. Mm-hmm. Mm-hmm. I've seen it way. No? Okay. There are n boxes with different quantities of candies in each of them. Highest box has AI candies. You also have n friends that you want to give the candies to. So you decided to give each friend a box of candies, but you don't want any friend to get upset. So you decided to eat some candies from each box so that all boxes have the same quantity of candies in them, so that you may eat different number of candies from different boxes and you cannot add candies to any of the box. Minimum total number of candies you have to eat to satisfy the requirements. Interesting. And now the answer equals to reapply minus 1. Should be most single words. You are given n words of equal length and consisting of lowercase letters or letters. Okay. In one move, you can choose any position in any single word. Change the letter at that position to the previous or next letter. in alphabetical order. A to D or F. A can be changed to V only, Z to Y only. Difference between two words is the minimum number of moves required to make them equal. The difference between best and cost is 1 plus 10, 0, 0, 0. Okay, find the minimum difference. Find the minimum difference of SI and SG. So set I is less than J. In other words, find the minimum difference over all possible pairs of numbers. What? And then the number of strings and their length. The minimum difference of SI and SG such that I is less than J. Oh, so it should go on -1 and cost equals 0 and and then the cost plus equals to absolute value SIK minus SJK. That's it, right? Then also equals to also equals to 11 and 8. Okay. A, B, and B, E. Like 1 and 3. Like where did I go wrong? Not what? Ah, it should also be. Grandfather gifted him a chess mode. To get his chess piece, this chessboard is a grid and rows and columns, each cell having a non-negative integers written on it. Challenge is to place a bishop on the board such that the sum of all cells attacked by the bishop is maximum. Can the bishop attacks in all directions diagonally? No limit on distance. The cell on which it is placed is also considered. Help him find the maximum sum he can get. Hmm. Like, what is the meaning of the integers? Ah, so is it like we'll place it on each square and then get the sum of all the diagonal values? But I think some DP is also using this. Otherwise it will exceed the time. Yeah. So, mm, so like for this diagonal, the sum of this diagonal plus the sum of this diagonal. No, this diagonal will not be considered. Sum of this diagonal or this diagonal or this one or this one or this one. Hmm. So how to store the diagonal sums? Like if I store it in an array, then which index will point to which diagonal? Like I can have this diagonal pointing to the zeroth index of the array, then this one will be present at the first index, second, third, fourth, fifth, sixth. So total number of diagonals would be n plus n minus 2. Yeah. Alright. Because in case of 4 rows, actually 0, 1, 2, 3, 4, 5, 6, so yeah, 7, n plus n minus 1. So d1 n plus 1 minus 1 filled in with zeros. For entire equal n minus 1, last row, actually let's not do it like this. It will be hard to find out the index in the diagonal vector. We can have a temporary variable, and now j equals to j will eventually equal to y, and j will also get decremented right? Yeah. So its maximum value should be up to m. Yeah. Let's call this x coordinate, and x must be less than n, x plus plus, and j plus plus. So initially j will be equal to 0. Like I will be considering the 0 column for each of these rows. Then sum plus equals to s of x and j, right? Minus alternative plus, so we know for it should be d1 by pb. Now some other diagonals are remaining, and for all of those the value of like the x coordinate will be 0. They will be total of yeah, it should be 0. So this will denote the column number. And x will denote the row number, which is initially 0. So while j is less than n, and okay, I should have another variable for the column number. While x is less than 9 and y is less than 9, sum plus equals to v of x and y. And x plus plus both of it, and after that given the question. So now diagonal sums. How to get the diagonal sum for the other direction. And then how to keep track of the element, like which element is included in which diagonal. Maybe that is easy. So the first element of D1 contains the diagonal sum for this diagonal, which contains only one element. Like for this element, only one diagonal will be considered. For these two elements, diagonal sum of this one and this one will be considered. For these three elements, diagonal sum of this one and this one will be considered. Actually, you know what? Let's use some extra things. And let's call it element sum. And now let's equalize and like this whole loop will run again, and sum map of x and j will store this value of sum, right? And similarly formula. So now when I calculate the diagonal sum like this, okay, so like the first diagonal that I will consider is this one, then that's equal, it will be the last row, yeah, and the ith column. So while x is greater than equal 0 and y is also greater than equal to 0, but actually the value of column coordinate will be increased So it should be less than and we do x minus minus and y plus 3. Before that sum was equal e of x minus and answer equals to maximum of sum max x and y from plus the current sum. And also minus v of x and y. Otherwise, this will get repeated twice. And the whole thing will go on one more time. Like all these diagonals have been considered. Now the ones for which the value of row coordinate is minus 2 and this one. The x coordinate is y. Column coordinate will obviously be 0. The row coordinate will be decremented this time also. The whole thing will be same. Line number 97. Out of bounds. Really? Okay. So that is fine. Okay, so measure is equal to the column coordinate will be implemented as well as the row coordinate will be implemented. Hold on. Should be initialized to 0. 21. Tamarind and candies. Ayat candy has a quantity of sugar equal to AI. So by eating the ayat candy, the immune consumes a quantity of sugar equal to AI. We'll ask you Q queries regarding these candies. For the jth query, you have to answer what is the minimum number of candies needs to eat in order to reach a quantity of sugar greater than or equal to x3 and minus 1 if it is not possible to obtain such a quantity. You should print a minimum possible k such that after eating k candies, timer consumes a quantity of sugar of at least x3 to say that no possible k exists. Note that you can't eat the same candy twice. Edward just sort them in the decreasing order, take the perfect sums and apply binary search, get the answer. Yeah, man, just one time I think that is what they want. And actually, okay, so now for the right now 0 1 2 and -1. So first of all, let v of I is that okay. So minus and x minus if v of I is less than x, then just out -1 and otherwise, and answer equal 0 while low is less than equal high and mid equal low plus 1 by 2. Just use binary search things. So if it is less than x, then do low equals to mid plus 1, else set answer equals to 0, then I equals to minus 1 and C minus one, two, minus 1, 2, 3, 4, 8. Should be fine. In an array A of length n and the integer k, you are asked to find out. You are tasked to find any two numbers L and R such that for each x appears in A at least k times. it has to find out any two numbers and that's is in between L and R. The value R minus L is maximized. Okay, so basically all the numbers. First, I will have to figure out like what are the numbers that are occurring at least k times in the array. Then we'll calculate this value R minus L. If no number satisfied, return minus 1. Okay, so then my guess number which is occurring k times and return minus 1. Without a constraint, we'll have to use a map. Or we can do sorting. Should we do? Yeah, actually sorting is required. Now, and also in previous we should initially be equals to -1 and also two more variables and previous is fine. Okay. Temporary left and temporary right variables should all point towards -1. Now while orbit I0 and I plus k can be 1 also. So if v of I is equal previous, then just do cnt plus plus, else if cnt is greater than or equals to k, then first of all cnt will be equals to 0, actually cnt will be equals to 1 and previous equals to v of I. And now check if previous if tr was equal previous minus 1, then answer will be equals to maximum of so L and R then answer left will be equals to so if answer L minus answer R minus answer L is less than previous temporary right minus temporary left, or actually this, then do answer r equals temporary r and answer r equals temporary I. So first of all, if temporary I is equals to -1, then temporary L equals to previous. Answer L equals -1 and answer R equals to or no. Yeah, we don't have any other option. Let's just check this and see and take one previous equals one. But the main issue is E. Like temporary right is equals to previous -1. E. E. And nice. Less. And then set the value equal -1 equal -1. Yeah, here it should be TR. Not actually. Should this be checked? No, I don't think so. So the right end of the previous range is equals to V of I minus 1. First of all, if CNT is greater than equals to K, then we need to update the right end of the temporary range, which means it should become V of I now, right? And accordingly update the range as well, the answer range. So TR minus TL is greater than equals to answer L minus answer L. Answer L equal TL and answer R equal TR. Right? So here we don't need to do that thing. Here the problem will be the case where CLT is equal to 1, where K is equals to 1. So we will do it like this. It is negative 1. So TL is equal minus 1 and TR equal minus 1. And set TL equal to and TR equals to 1. Both will be seen like this, like this. And then here the temporary range is greater than the answer range, and that is otherwise but in this case they are not -1. Then check if tr is equals to vi -1 or not. If it is, then update it. Else, if tr is equal y is equal vi, then do nothing. Else, tr equal vi and tr also equals to vi. 1340 volts. This should be fine. Okay. That is fine. In 14 minutes, it was okay. Okay. White black balance subtrees. You are given a rooted tree, a system of n vertices, 1 to n. Root is vertex going. There is also a string x denoting the color of each vertex. If si is equals to b, then vertex I is black, and if si is blue, then it is white. Subtree is called balance. Number of white vertices equal to number of black vertices. Count the number of balanced subtrees. The tree is specified by an array of elements and -1 numbers. Yeah, the root is vertex. This should be easy, right? This one is, I think, a very common CP problem nowadays. The recently code contest also similar problems there. No. So this is our DFS function, which will calculate the sum for all subtrees and child and adjust of the child is not present, then answer plus equal, and also one more time as Candies DFS adjust child and present answer equals this of present, so it is W, then 1 else minus 1, right? And also, if answer is 0, then count this. I think they should be no. Okay, let's read it again. For 4, the answer is 1. Okay. For 6, the answer is 1. So, alright. 5, answer is 0. Okay. For 3, also the answer is 0. For 5, how does it become 0? It never calculated the answer for 6. H1 maximum crossings, limit of n. A terminal is a row of n equal segments numbered 1 to n in order. There are 2 terminals, one above the other. You are given an array A of length n. For all I 1 to n, there should be a straight wire from some point on segment I of the top terminal to some point on segment AI of the bottom terminal. Some straight wire, some point of segment I. 2 possible wirings for n equals 7. We are not 4, 1, 4, 6, 7, 7. Okay. What is the maximum number of crossings there can be? You place the wires optimally. So basically, the minimum number of strings. So the number of crossings due to the 7 will be equal to the number of wirings oh, yeah, that are after the connecting segment of 7, like which is 5 in this case, that are ahead of this 5, like 6, 7 and all the other ones. And they all are connected by the points which are before 7. Okay. And the equal ones are also similar. Like this 5 is also connected to 7 and 6 is also connected to 7. So they both are also close to each other. So actually not the minimum number of copies from maximum number of copies. Optimally means that we are trying to maximize the number of crossings. Without that maximum number of crossings, we are trying to minimize the number of crossings. Okay. So yeah, the answer approach is quite simple. So what are the constraints for h2? 2 into 10 to the power 5. So some analog and approach. What are the standings? Oh, now I think it is easy. It can be solved using the ordered set as well. Let's try to solve it using ordered set. I haven't used ordered set ever. So what will be the ordered set? Yeah. I think it is used like this. Convert issue unify and answer plus equals to st.lower one. No, I don't know what this on find by order and order by creating. Order of is let's look at this now. If 0, 0, then 1 offsets, it returns 2. Is not having duplicate values. How to store duplicate values? If I put pair of integers, not sure how that will work. Okay, I got now it will store duplicate values. Okay. I can do it using segment for sure, but I think that will be overkill. Oh, okay. Action. So if I'm not wrong, the SD dot size minus IT, the sugar. Long answer on test quiz 3. Interesting. Ah, okay, never mind. Okay. Mm, for the second four, what value of IT equal 1, which is right. Okay. Oh, mm, I don't think it should be there. That's fine. Mm, maybe swatching this one. Looking to 5 minutes. Let's discuss the solutions of the. So in problem A, we are given a string of 6 digits, just one line. Very simple problem. Nothing to explain here. Just find out the sum of first 3 digits and the last 3 digits. If they are equal, friend pairs, otherwise no. And so the only thing that you might have not done that, the only thing that you should do is that you should take the input as string, not as an integer. If you take it as an integer, that one also works, but if you take it as a string, it will be better. You can access the element using these indexes, and if you are taking it as an integer, then you will divide it by 10, take the modulo, add it to sum, subtract from sum is 0, yes, no. And this was a small thing that you had taken as a string. You could have solved that problem. Problem B, full candies. Yeah, so we are given an array of integers and we have to distribute each number of candies. So there are n numbers, basically n boxes of candies, and there are n friends, and we have to give one box of candy to each of the friends. Each friend will get one box of candies, and what we want to do is that all the friends should get equal number of candies. So that's not an page. Equal candies is this problem. And let's keep down to the. So in the first case itself, we are having one box of 1 candies, then I don't know how to draw it. Let's say like this. So there is one box which is having 1 candy, then the other box is having 2 candies. So I'm drawing it like this, but I think you will get the point. One box is having 3 candies, other one is having 4 candies, and one more which is having 5 candies. So you can see that if we want to give equal number of candies to each friend, then it is not possible to transfer candies from one box to the other one. So if it is having 5 candies, then we are not allowed to, let's say, transfer 1 candy to this one and 1 candy from this one to this one. If we do it like that, then I think the minimum number of candies will become 3. Just the sum of all numbers divided by number of friends, but that's not the case here. So the minimum number of candies that each friend will get is the minimum number of candies that any box is having. So since one candy is the minimum number of candies in any box, so each friend will get one candy. I mean the box with only one candy. So each of the remaining candies will be eaten by us. Yeah, eaten by your food. So yeah, we figured out the minimum element. Let's just quickly look at the code. Here I figured out the minimum element of the whole array. And then I'm just adding the minimum, the difference between the number of candies in the current box minus the number of candies that the friend is going to have. For this case itself, the answer would be 0 plus 0 plus 1 plus 2 plus 3 plus 2 will be 10. This one was also a very simple problem. Can be done in big O and time. Now the third problem is most similar words. You can solve this problem in n log n time also, but like why to do it in n log n using some binary search, but use db and solve it very often. Most similar words. You are given n words of equal length m consisting of lowercase written letters. Yeah, so this problem was also like all the problems that I saw in this contest were just simple implementation based and nothing extraordinary thinking was required to solve the problems. So they basically test your implementation skills through Div-4 contest, and yeah, your implementation skills will improve a lot. So like these problems were also, this problem was also simple. So in n square time, you can find out how much time, what will be the cost to convert a particular string to each of the other strings, and the cost will be, and the answer will be the minimum of all possible costs. So how they are defining a cost is that the cost of converting ABV to ZBL, please don't capitalize it, is equal to yes, like in this case, so the index of A is 1 and index of Z is 26. So 25 for this one plus B and B both are same, so index will be same. the difference between the indices will be 0, and here the difference between indices is 1. The total cost is 26, and and to convert ABV to BEF, which is the answer also in this case, for this one the cost will be 1 plus 3 plus 4, which is 8, and that's what the answer is. And you can find out, like, you can calculate the values for all other ones. The answer will be 8, like the minimum cost will come out to be 8. Just quickly look at the code. Here I am initializing the answer to into max, and just adding the absolute values of the difference between the indices of character K of a string Vi and string Vj, adding it to the cost and finding out the minimum answer, and just outputting. So this problem can be solved in n into n square m time, and that's what they wanted. It will pass according to the time limit. Just 2 seconds. Problem B, x1. So this problem was kind of interesting. Let's add another page. I don't know if I can. No, in this problem, we are given a chessboard of size n cross m, and we want to place a bishop at some square such that the maximum number of the sum of all cells attacked by the bishop is maximum. So as you know, if the bishop attacks the diagonal squares, like if it is placed at this square, then it will attack all these squares. So this problem was also a DB based problem, and what I did is that I used a map, or you can say I just had another grid like this where I was storing the diagonal sums. So like if the bishop is placed at this square, then at this position in the grid I was storing the sum of this diagonal. So when I was calculating the sum for all the diagonals that are 90-degree vertical to this diagonal, like for this one, these all diagonals, then what I was doing is that, so this diagonal includes only this element. So in the sum map, I was having the value 2 stored at this position. So like the answer, at the end the answer will be the sum of some diagonal 1, the sum of some other diagonal d2, and minus the common element. So let's call it Vij. So at the end, the maximum of this value will be our answer. So when I am calculating the answer for the diagonal sum for, let's say, this one diagonal, then what I will do is that first I will calculate the sum, then with the help of that sum map, which I can show it here. So this is the sum map. This is like, you can consider it like another grid only, and in that grid at this position we get this 2. I'll be having this sum stored, the sum of this diagonal. So the sum of this green diagonal, which is 4, will be stored at this position as well as at this position. So when I will take the sum of this diagonal, which is 2 plus 2 plus 1, 5, that one is 5, then I will add the diagonal sum for this one, which is 4, and subtract the common element, which is 2 in this case. So it will turn out to be 7, and this way I will calculate it for this one as well. So 5 plus diagonal sum for this one, which is 7, and minus 2, it will be 10, and so on. Like this I will calculate for each of the element and find out the maximum sum. So here I am storing the sum in the sum map grid or a vector of vector 2D array, and yeah, here I am calculating the value of answer and checking if it will update my answer variable, then update the value, otherwise leave it as it is, and at the end just print out. So the time complexity for this one as well will be n into m. So as of now, no problem. Needed binary search, like all have been solved in linear time. Now this problem, eating queries. So there are n candies and each candy contains ai quantity of sugar. So a person wants to eat, let's say, x quantity of sugar, then how many candies he will have to eat? So let's take this example in which there is something. Let's see. So person wants to eat 3 quantity of sugar. Actually this example is not so good. I think I will have to take just simple recipes, not a choice, and some queries. So I am having candies with sugar 4, 3, 3, 1, 1, 4, 5, 9, and I want to eat 10 quantity, let's say 10 kgs of sugar or whatever, um, um, whatever unit you consider in your country for measuring and anything. Let's say in India we use kg, so we are having 10, we want to eat 10 kgs of sugar, and we are having candies with 9 kgs, 5, 4, 1, 1, 3, 4, 3 kgs of sugar. So why not I should eat a candy with 9 kgs of sugar and 5 kgs of sugar? I mean, we want to eat the minimum number of candies, right? Mm, yeah, minimum possible. So spread after eating cake candies, then it consumes a quantity of sugar. At least X, yeah, at least X J, so that means we can have more than X J quantity of sugar as well. So yeah, it is just optimal to eat the candies that contains the most amount of sugar. In this case, like when we are talking about 10 kgs of sugar, we should have 9 plus 5, 14 kgs of sugar. Right? If you take it like this, then it will be 10 kgs of sugar, but you will have to eat 3 candies, which is not optimal. You can you can take 9 and 1 as well. Like why not eat 14? So in the code as well, I am just sorting the elements in the decreasing order. This greater name function sorts in the decreasing order. Then there's the prefix sum array, which will contain the sum. So like first I will sort them in the decreasing order. It will become 4, 4, 3, 3, 1, 1. Then the prefix sums 9 plus 14, then 18, 22, 25, 28, again 30. And then I will do binary search. I think we can use lower bound, upper bound functions here as well, but yeah, I just did it like that. So we, yeah, I think using lower bound was much simpler. I mean, basically, both things will do the same. So just binary search on 10 and find out the lower bound for 10. So in this case, the lower bound will be here. So just print out, like we will be requiring 2 candies, so just print out 2. In this case 50, so we cannot have 50 kgs of sugar even if we eat all of the candies. So here I will output -1. For 14 also we will require only 2 candies of sugar. Yeah, so this problem required binary search so that and complexity was and login. Now problem F and problem G. In problem F, we are given an array A of length n and an integer k, and we are tasked to find any two numbers L and R. Hmm. So yeah, let's read the complete problem. For each x appears in A at least k times. So x is basically any number which is occurring in this given array k times, at least k times. So if we are considering this one, for this array, the value of k would be, the value of x would be 11, 13 and 14, right? And for the next case, all the values are valid and the value of k is just 1. And in the next one, no value of x can satisfy the given requirements of k. And in the last one, the value of k is 2, so x equal 1, 2, 3 and 4 all will satisfy, right? Then the value r minus l is maximized. So this way we need to find out first of all the values of x that will be that are having its occurrence more than k times, at least k times, so greater than or equal to, and then some range. So basically for this case we will say that all elements including 13 and 14 and in between 13 and 14 are occurring at least k times in the given array. So in this case, all the values between 1 and 3 are occurring more than or at least k times in the array. In this case, all the values between 1 and 4 are occurring in this array at least k times. So this way we just had to find out the maximum value of r and l and r. So the difference between r and l should be maximized. The range must be maximized. Like the value of r and l should not be maximized, but the difference between them must be maximized. So yeah, in the contest, just to save this little time, like this extra log factor. So for this one, you can have a set. First, you can sort all the elements and then just find out the frequency for each element, and if it increases or becomes equal to k, then you can push it into a set, and yeah, this way you can do this problem in n log n time. And actually I think you don't need a set, you can use the vector also. Yeah, so that extra log n factor is also not required. But in the contest, how I did is that I solved it in one iteration itself. And without using any extra space. So just to reduce the time complexity, I did it in a bit complicated way, but that's fine. Actually I should not waste it. So here I am finding out the frequency or the number of occurrence for the current element. And then if it is not equals to the last element, then the value of count will become 1 and the previous value will be updated. Then if the count value exceeds k, becomes equal to k, then I will update the value of answer L and answer R, which are the main range that will output. We will update the value of answer R and answer L if like the value of temporary R minus temporary L becomes better than answer R minus answer L. So this one was also just an implementation based problem, and no extraordinary thinking was required to solve this problem. So this problem will also require n log n time, because we either need to sort the array or take a map to count the frequencies, but that will be a more complicated way. Yeah, and this constraint is, we cannot satisfy these constraints in linear time. So yeah, either sort or use a map. I think sorting is the best way to do. Yeah, this was it for this problem. Problem G and problem H. Problem G is also a very straightforward kind of implementation based problem, in which we are given a tree. So we are having a tree, and some color is assigned to each of the node of this tree. So like this, node 1 is assigned color W, and this node is assigned color black, and so on. And in this way, we need to calculate the number of black nodes and the number of white nodes in each of the subtrees. So like the value for this subtree, the count for W and the count for black will be 0 and 1. For this one, it will be reverse 1 and 0. And for this one, it will be 2 and 2. So this way, if the value of this count is equal, like the number of white nodes are equal to the number of black nodes, then we will increment our answer count, answer plus plus. Otherwise, just ignore it and check out for the next subtree. Like in this case also, 1 equal 1. So the answer will become 2. And overall, like this one will not be balanced. Yeah, so the answer will be 2 in this case. So just a straightforward implementation based problem. And I think it kind of requires DP, but not really. So the code for this problem. Yeah, just this DFS function. You just need to write this DFS function and it will be quite easy to do. So initially the value of answer variable is initialized to 1 if the color of the current node is white or otherwise minus 1. So in case of white, I am having 1. In case of black, I am having minus 1. Right. Now for each child, I will recursively just add this value of this answer variable for all the subtrees to my current value. And this way, if the value becomes 0, which means the whole subtree is balanced, then I will increment the count variable and return answer. Answer denotes the sum for the current subtree. So it's just simple DFS function. You can solve this problem easily. Nowadays I am like finding out such problems quite frequently. In the recent lead code contest also, there was such a problem in which we were required to write a DFS function to calculate some values for each subtrees, and then just like that. And in the CS problem set also, there was a problem. This subordinates problem. So it is just a variation of this problem, I would say. So you must try this one also. This one is much easier than this one. Actually, not much easier. Like the difference would be just one line of code. So that's it for this problem. Now, these two problems were like the difference is just the constraint on n. Here the value of n could be up to 2 into 10 to the power 5, and here it could be just 1000. This problem I solved it using an ordered set. Add a new page. So a terminal is a row of n equal segments numbered 1 to n. So this is a terminal. So these are the segments, and 1 denotes one terminal, 2 denotes the other terminal, 3 the one, and so on up till 7. And they are numbered order as well. And you are given an array A of length n. For all I equal 1 to n, there should be a straight wire from some point on segment I of the top terminal to some point on segment AI of the bottom terminal. So we are given an array that's this array 4 1 4 6 7 7 4. So this 4 denotes that this fourth segment from the top is connected. No, this first segment from the top is connected to the fourth segment of the bottom, and this second segment of the top is connected to the first segment to the bottom, and this third segment is connected to the fourth segment. So we just want to make these connections and maximize the number of crossings. The crossing is like they have shown it here. These red circles denote a crossing. So whenever there is one connection which is connecting two segments, so if some other connection is crossing that segment, that there will be one crossing. So since this connection is crossing 3 other connections, this one, and this one. So there are 3 crossings like this, and we just need to maximize these numbers of crossings. So first thing you need to realize or understand is that when will we have a crossing? So we'll have a crossing only if, so whenever we are connecting a segment to some other segment, let's say this one, and the other segment is connecting a segment which is before the segment which has been connected, which has already been connected. So like if we are taking this example, so we are connecting to 5, but this 6 and 7 have already been connected. So the number of crossings will become 3 since this 7 is connected twice. So as you can see that there is some pattern. So for this 7, the number of crossings is just equal to the number of segments which are ahead of the segment to which 7 is connecting. So for this one, there is, so no other segment is connected when we are connecting 1 to 4, and when we are connecting 2 to 1, 1 has already been connected to 4, right? So let's say we are having some other data structure in which we are storing like what are the segments that are already been connected. So 4 has been connected, and when we are considering 2, when we are connecting 2 to 1, we see that 4 has already been connected. So the number of segments that has already been connected and the segments which are ahead of this one will be added to our answer. So the answer will become 1 when we connect 2 to 1. And now the 1 is also connected, right? Now when we are connecting 3 to 4, so we can see that 4 has already been connected, and 4 is like not ahead of 4, but just 4 is equal to 4, so it will also implement our answer. 4 has already been connected once, and we want to maximize the number of crossings. That's why we have to take this 4 as well into consideration. So like in this case, they have been taken 4 just because they want to show that what is an optimal wiring. So this one is an optimal wiring, and here they have crossed both those 4 connections. And when we connect this 4 to 6, so no other wiring is there which is ahead of 6 and has already been connected. Like no other segment is there. Then we are connecting 5 to 7. Again, there is no other wiring which is connecting any segment which is ahead of 7. Now when we connect this 6 to 7, 7 has already been connected once, so we will implement the count. And then we are connecting 7 to 5, and so next 7 has been connected. So now the answer will be incremented by 3, so it will become 7. So it will become 6. So yeah, if you understood this much, then figuring out this data structure and querying it is just the matter of knowledge, I think, or just a matter of experience. I don't know what to say. Like what is the correct word to say that thing? So I just use an ordered set, EBDS, policy-based data structure. So you can see that storing these values in increasing order is not a big deal. You can do that using a set also or a multi-set. But if you use a set or multi-set, then you will not get the number of values. Like you will not get the index when you will query. Like you are querying, if you are querying for 5 in this case, then you will not get that index. That 6 is present at index number 3. So to get that index, we use ordered set instead of set. Otherwise, and set or multi-set would also work fine. So yeah, I just use an ordered set, and the one wrong answer was due to integer overflow error. So I use the long name tag here. Now this order of key returns the index. So like for 4, if I query here for 4, then it will return the index 1. And if I query for 5, then it will return the index 3. So this way I am finding out the index, storing it in IT, and subtracting it from the total number of elements present in the set. And then this will be the number of segments that are ahead of the current segment and are connected by some byte. And yeah, and then just printing out the answer. And this is a short trick. I have to use pair of integers just because ordered set does not contain duplicate value. And at the time of querying, I am putting here -1, which just denotes that if we are talking about this 4, then this 4 will not be stored like this. It will be like 4, 0, and this 4 will be 4, 2. So when I am asking for 4, -1, then it will start the count from here. Like this index will be returned since it is the first value which is bigger than this, greater or equal to this. Order of E, I think, returns the index of the element which is greater than or equal to the current element, not just bigger than the current element. So yeah, this way it's all discussed. So the code for H2 also works for H1, and the constraint is just on the yeah, let's check out the standards one more time. Why is it not working? So 856 final that one wrong answer. But that's okay. So this was it for today. We'll meet in the next video.